Hey, what's up? My name is Andrew and this is my tutorial about the const expression from C++11 in the C++. So pretty much here I have a pretty basic example of how it works with objects, which are classes in C++, or maybe structs, but in this case it's just a class, and how it will work with just variables and how it will work with just functions. So in this example you can see that the variable u is declared at runtime and its value is 7 because it equals to a return value of just making a sum of two ints which are 2 and 5. And you can see those calls right here. I'm using the codebot and it's calling the function is doing its stuff. But we are doing this at runtime and we already know this is going to be 7, and let's say this function does some crazy stuff with math and you can still kind of predict what value it is, but you might still use it for other reasons. So C++ allows you to evaluate certain things at compile time by using the Constexpr keyword. This way, as you can see, I had a typo. The C++ already knows it's 7 and only assigns 7 to the u variable, and that's actually cool. I skipped the whole call of the function, I skipped the adding, and it only runs on the compile time. But we can also use that for other constants. For example, we have const expression float pi, which will be equal to 3.14, and let's say we're doing some crazy math stuff. So const expression float val that equals to pi times 180. But let's say this equation is in some for loop, or it's in some crazy function that's called multiple times. You can optimize that in a way that and this value is not const expression. And this thing, let's say you have to use that and it cannot be const expression, it cannot be evaluated because you are doing something else. But since you have those static values, you can just create another const expression. Let's say this is also plus random number, and random number will be like this. And let's assume that this is actually a real random number, like it's randomly generated and we don't actually know its value. So in this case we know those values and we know the result of multiplying. We can just get it and create a const expression float, let's call it multiplier, that will be equal to the result of this multiplication. And this way I'm doing this only once and I can already use that in my assignments to a certain value or just a function call or whatever without calculating this multiplication, which can save some time if you have lots of calls on that. Also, if you declare something const expression, let's say function, you can still call it at runtime. It just gives you the opportunity to call it at compile time, which is pretty useful. For example, this u is declared at compile time and I can use it for something because this function can be called at compile time, and this is pretty cool. Also, you can create objects at compile time. I have this human, and I'm just implementing my stuff. I have a human object that has an variable age and has a function that returns whether or not he's an adult. And in this case, I'm just making a legit or whatever in a compile time, not at a runtime. I already know whether or not a created object, in this case, is an adult or not. And you can actually use that for lots of stuff. Let's say you have some animals, you have some shapes or whatever, and you can store lots of stuff actually at or calculate at the compile time, and this way you save lots of runtime overhead. So this is a really cool way. Like this thing it's not at compile time, and on runtime it's not even called. In my opinion, it's a huge optimization, and I hope you learn something from that, because this will be it from me, and I hope I see you in the next ones.